In this lesson, we're talking about tree diagrams and calculating probabilities from tree diagrams. Now, we've seen these types before. They are when we have multiple events in a row. So you might be flipping a coin twice. That's this example here. We know that the first trial, in the first flip, you have a possibility of heads or you have a possibility of tails. And that when you go through that second multi-stage event, so the multi-stage event is what we're doing here, and we're into the second stage, we know that there's still the opportunity for heads, tails, okay? And we've represented things like this before in Year 9, and we now need to use it to calculate some more probabilities. So let's do our first example. So we've got 2 bottles of wine, randomly selected for tasting from a box containing 2 white and 2 red. So use a tree diagram to help answer the following. So we have to remember that there's 2 different ways of doing this. Let's say I'm going to choose the bottle of wine first, and then I'm going to put it back and then go again and select it again for whatever reason. I'm not going to drink the wine. So let's draw this up first of all. So in our first stage, we know that there's 2 stages. Our first stage, we can choose a bottle of red, another bottle of red, a bottle of white, or a bottle of white. Okay, they're our only options. Then I'm going to put it back and go again for our second round. Now I know that in my second round, the same thing is going to happen, and you can see that these are going to get really, really big. Now I've done a really dodgy job of this, so I'm going to start again, and you might like to consider the same thing when you're doing these. So red, give yourself some room, red, white, and white. We know in our second one, I'm going to have all the same opportunities. Red, red, white, white. And we would keep going like that until I have filled out every single combination. Now, at the end of a tree diagram, you should be writing up your sample space. So if I go through the tree and go this way, from here to here, then my first option is red, then red. Then I'll do the same thing, but I'm going to go to the next branch. Red, then red. Same thing. Then red, then white. Then red, then white. And so on, and so on, and so on. Now that's going to give us 16 possible outcomes when you do that on your book, and I would recommend you pause and actually do that. If we now go to this one, however, it says without replacement. So this time I'm actually going to drink the wine, so there's no point by the time I reach back into the box to get that second bottle of wine. That first one's not going to be there anymore. So I can take my first step. I'm going to have red, red, white, white again, but this time on my second grab, that red one's not going to be there. So there's only one red left. There's a white and there's another white. So I can keep going like this, knowing that there are only 3 bottles left, and whatever I have already had, I cannot have again. So when I get down to here, there's still 2 reds left, but now there's only 1 white. Okay, so same thing here, 2 reds and a white, and our sample space will be smaller. Okay, to look a bit different. We'll still have red, red, but we only have one of those opportunities, because once I've had that bottle of red, it's going to disappear. So in this particular case, we've only got 12 options in our sample space. Okay, so that's drawing them up and putting our sample space down the side. Now that sample space is going to help us do some of these problems, because the first question says, if the first bottle is replaced, so that's this particular tree diagram, our first one, before the second is selected, fine. The probability of getting 2 reds. So I'd have to go through all of these and find how many times it is possible for me to have chosen 2 reds in a row. Now I can see that that is going to be the probability of 2 reds is going to be 4 out of my total 16, which is 1 out of 4. If I come over here and say, all right, let's make it a bit more confusing. I've got to do probability of not 2 white, not 2 white. So anything but white, white. And that could be a combination of red and white, or it could be our red, red again. So again, you'd have to go and calculate all of those, or count how many of them are in the sample space. When we get to these types of ones where we said, if the bottle is not replaced, we're back to our second tree diagram, okay? So doing these again, you're going to have a different total. Remember, we only had a sample space of 12, so I'm not going to have those 16. And when we try and get 2 red, if we come back up to our full tree diagram, how many times do we have red, red? Well, there's 1 there and there's 1 there, but we certainly can't do it more than twice. So our total is going to be 2 on 12 or 1 on 6. If we go here, probability of not 2 white, same thing. You need to have a look for lots of other lots of other combinations. Now, this isn't new work. That's all covered in Year 9. But what's tricky about this now is using it to calculate some probability. Now, instead of having to draw every branch of the tree diagram, what we can do is say, all right, let's just make it really simple and show what our probabilities are. 2 prizes are awarded to a group of 3 male and 5 female candidates. Copy and complete each tree diagram, including the missing branch probabilities. Now, this is with replacements. That's assuming if I have pulled a male's name out of the hat, I can then put him back in and he can get another prize. That's not always the case, but in this case it is. So my first draw, I can potentially pull out 3 out of 8 men. So instead of having to draw 8 tree branches, I can just represent it this way, okay? Once I've picked a man, what's going to be 3 out of 8 opportunities here, and this one will be the remaining 5 out of 8. Same thing when I get to the second draw here. Even though I have drawn a male name out, I can put it back in again, and there's still a 3 out of 8 opportunity that I can draw a male name, and there is still a 5 out of 8 opportunity that I can draw a female. Same thing down here. It's going to still be 3 out of 8. Now we calculate probabilities by multiplying these together. So if we chose a male and then a male and I followed those 2 branches, I would be doing 3 out of 8 times 3 out of 8, and that's what we would end up as probability. If I followed all of these tree branches across, and let's just do this one here. Let's fill out our sample space firstly. So female then male, FM, and female then female. That's our entire sample space, only 4 combinations running down this section here. Our probability of getting a female than a female looks pretty good. It's 5 out of 8 times 5 out of 8, and that will give us 25 out of 64. And we could do that for all of this. Now, if we scroll down and say, okay, this time once you've won a prize, you don't get to win another prize. This is what it will look like. Very similar, but we know if we start off, we've got males and we've got 3 males out of the 8 possible people, and we've got 5 females. Okay, makes sense. However, once I've pulled 1 male name out, firstly, we now are down to 7 candidates left in the running for a prize. And instead of having 3 males, we now only have 2 left because we've already drawn 1 out. So this time our male-male combination will have a probability of 3 out of 8 times 2 out of 7, which will give us, if we remember how to multiply our fractions, 6 out of 56. Let's do the same thing for this pathway. Let's say I pulled a female name out, so no longer are there 8 people. Suddenly there are 7 people to choose from. I've already pulled a female name out, so we're going to reduce the female numbers by 1, and now there are 4 out of 7. So my combination of female-female will be 5 out of 8 multiplied by 4 out of 7, and that's still quite a big number. So there's 20 out of 56, and you could do it for these 2 as well. So you need to know how to draw a tree diagram with and without replacement. All right, remember if someone can get a prize twice, or if I can drink a bottle of wine twice magically. And then we need to know how to use those tree diagrams to calculate probability.